Hello and welcome to another tutorial. We are going to continue our discussion on more on classes and look at understanding class members, which was basically a static part of the class, right? The static part is the part that is not really concerned with a particular instance of that class of type, or basically it's a state of the class itself, and you access the static fields and static methods via the name of the type itself. Fully qualified name. In these examples, again, people usually don't show the fully qualified name, but in general, in theory, you have to always use the fully qualified name. Or maybe you use imports, or if unless you're in the same package, right? If you're in the same package, that's the default behavior. That's the default behavior that the compiler and the JVM expect. Therefore, you don't need to use the fully qualified name, but obviously some people prefer as the style of coding to use a fully qualified name. You can even configure your IDE to when you basically to clean up your code in a way that it replaces every name with the fully qualified name. I will probably show you at some point in the future lectures how to do it, but for now, when you see some example like this, the name of the type is just a bicycle, it means you can assume that we are in the same package as where this type is defined, this class definition is defined. So you can access the static state via even an instance, a reference to an object, an instance of a class or type, but that's not recommended, and normally you get a compiler warning, for example in Eclipse, because you have to, the static is not really related to a particular object, it is shared amongst all objects, everybody can access it, because a static part of the state of the class is still part of the state of each individual object of that class, right? But objects share the static state with each other. So non-static state, everybody gets its own copy, a separate variable, a separate memory location. Static state, everybody looks at the same memory location where the static fields are stored. Alright, and we saw this bicycle example that we have this private static in number of bicycles, and we said that one of the use cases obviously is to keep track of how many instances of this class have been created, and the idea was that you create a static field, and normally you make it private, number of bicycles, and you initialize it to 0, for example, and then in each constructor that you define for your class, you just increment the number of bicycles, increment this counter. And the reason this works is that, first of all, in any non-static context like a constructor, remember I put an emphasis on this, that constructor is always a non-static context. That's an important rule, that constructor has to be non-static, because it's supposed to initialize the non-static state of the object, right? It's supposed to allocate memory for the non-static part of your class and then initialize them based on the parameters that you pass. But then in a non-static context like a constructor or a non-static method, you can still access the static part. That's fine. So, and then we know that whenever somebody wants to create an instance of this class, the only way in Java that is possible is to call a constructor using the new operator, and then therefore one of the constructors has to be called. So in all the constructors, you just increment this number of bicycles, and know that here it uses a prefix notation. We know that what happens is that, first of all, we have an assignment operator, so the right hand side is going to be evaluated first, and then the return value of that evaluation is going to be assigned to the left hand side. So what is the return value of this expression, plus number of bicycles? We know that the prefix increments the variable and then returns the new value. So we know that the increment prefix increment operator returns the new value, right? The result of this expression is the new value for this number of bicycles, which becomes 1, right? So id starts from 1, and then know that id is a non-static part of the state, but the number of bicycles is the static part, right? So right now there is here id and number of bicycles is the same, but it doesn't have to be. For example, you can create a hash code or assign some sort of a string based on the number of bicycles. So id doesn't have to be the same as number of bicycles, but in this simple example it is, right? So one of the most use cases of a static field is to keep track of how many objects are created. Now the same story happens if you want to keep track of reference counting. Reference counting, if you've heard this terminology, is the same thing. You keep track of how many objects are created, and then once the number of objects, and then if your objects allow destructors, then basically you decrement the number of objects, and then once this goes back to 0, you destroy the memory that was allocated. So let's say you have multiple objects share the same memory. Now in Java, this kind of story that I'm telling at the moment doesn't make sense. I will show you an example on when it becomes important, and that's when you try to use Java to manage some native resources and some memory, and using the JNI bridge Java native interface. If you're not familiar with that, go ahead and check out my lectures on Java native interface, but I will show you what happens in that case. So you create a Java wrapper for a C++ class, and then you allocate some memory on that object on the C++ native heap, right? And then just keep a pointer to that. But then what you want to do, you want to also implement some sort of reference counting in a way that if somebody creates multiple of those objects in C++ using your Java wrapper, then whenever you want, what happens is that you want to release that memory, because remember in C++ the memory management is basically manual, right? So you want your Java wrapper to basically release the memory when all the objects of that class have been destroyed. And you can implement some sort of a static counter like this, and then once this goes up to some number and comes back to 0, then you realize that everybody has been destroyed, all the objects, therefore now the memory can be released. And this is the whole idea also of smart pointers in C++. Unique pointer, or for example shared pointer. Shared pointer is exactly the same thing. They have some variable that is reference counting. It keeps track of how many times memory has been allocated, and then once it goes back to 0, then the memory is destroyed and deallocated. So I will show you an example later on using JNI, but for now this is one of the use cases of a private static state, right? Keep track of how many objects are created. Class methods. Class methods are same with class members. A class member or class variable or the static fields. Class methods are static methods, right? Static functions inside the class. The Java programming language supports static methods as well as static variables. And again, the whole idea of a static method is that we said that in general, there are some functions that more like utility functions, right? You pass some parameters to them, and then they do some calculations and give you back a result. So it's like a purely function idea. They don't really rely on the state or the data of some particular object, right? So some functions don't really hold any don't have any dependency on a particular object. And obviously math functions are the prominent example. For example, if you want to calculate the sine of a number of some angle, right? It doesn't depend on this function. You just give it a parameter and you get a result back. It doesn't depend on a state of object or anything. In this case, these functions, like a sine function, cosine function, these are supposed to be freestanding function, and they are supposed to be globally available. And therefore, for example, in C++ or Python, whatever, usually you put them in some sort of global scope. And we said that over and over that Java doesn't have any global scope. Therefore, every function, every method has to be inside the scope of a class. But then the question is, how do we make some functions freestanding without relying on the state of the object? Because if I put my method in a class, and it has to be in a class, then it's going to depend on the state of the objects of that class. I have to create a new object of that class first in order to access that function. But the solution that Java provides is a static methods. If you add a static modifier to the declaration of the method, then the Java compiler and the JVM know that, hey, this method is kind of like a freestanding function. It doesn't rely on a particular instance of this class, because remember, this method is eventually going to end up in some sort of class scope. But then now we get more flexibility here, because now this method, first of all, I can directly call it without creating a new using the new operator to create an instance. So this gives an illusion of freestanding function or method. But then this static method has a little bit more capability in the sense that it can actually use the static state of the class. Because remember, every method has to be inside a class. Static methods can access the static state of the class. So there's more flexibility here instead of like when you compare it to a freestanding function in a global scope. Now, for example, we saw that one of the main use cases of the static members are constants or math classes, utility classes. So basically utility classes. We define this class. We said that it's best to make it final so that nobody can override or change the implementation of any method. And we make this final public because we want everybody to use this, right? That's the whole point. We don't want to hide this. And again, we saw that for example, the math class, let's look at JDK 17, is exactly the same example or the prominent example of a utility class. As you can see, this math class has some static state. And we said that the static state is usually where we define the constants, mathematical constants or physical constants, right? These are compile time constants. Wherever in your source code, you use this symbol from the scope of this math class. You say math.e. Compiler at compile time replaces that statement with this number. It's as if you actually wrote this number, right? And then there are some helper, for example, private values, right? These are still compile time constant, but these are used in, for example, some of the functions, 2 radians. It just gets the angle. And again, a static member or a static function, this was supposed to be freestanding, but we cannot put it outside the scope of the class. So we put it in the scope, we make it a static. So people kind of know that they can directly use this method without creating an instance of the math class. To make it even more explicit, we make the constructor private so that people don't even try to attempt to create an instance of this math class, right? And then you see that this math class has some static state, and that static state is used inside this method. But again, it doesn't cause any problem for directly accessing these 2 radians. So let's create a class, utility class demo, right? So let's say we say var x is math.2 radians, right? Let's say 90 degrees. And then sysout x. Now this is a freestanding function. We cannot put it outside the scope of a class, so it has to be a scope of the class. So this is called a static method, and this is supposed to be freestanding function. This is as close as we get in Java to a freestanding function. Now Java provides a way to actually make the illusion that these are freestanding. So the way that Java allows something called a static import for static methods, right? And static fields. Now the way this works is that, let's say I want to use this everywhere and use this function a lot of times. And let's say right now math doesn't need an import statement because it's part of the Java Lang package, so it's implicitly exported. But in general, again, we have to use the fully qualified name, Java Lang Math, for example, right? Or use an import statement. Sometimes this is tedious, and so we can make this function as if it's like a freestanding function in the global scope. So we can say import. I want to import just this method. So Java allows importing a static method. So import a static math.to basically, but here we have to use the fully qualified name, Java Lang math.to radians. So here in the import we have to use the fully qualified name. And then now what happens here is, instead of saying that math to radians, we just say var x is 2 radians. Now you see Eclipse autocomplete also shows me that this static method 2 radians is available. So 90 degrees. Again, this gives an illusion that this is a global function. This is a function in the global scope, but that's not the case. We just manually imported them in our application so that the compiler knows what we're talking about when we say a 2 radians function, right? And the compiler knows, oh, you have an import, and okay, it's this function or method, and it's a static method, so you are allowed to use it without creating an object, right? So if you run this, it's going to work fine. Yes, 157 is pi over 2, and var y is same with the other one, right? So let's say let's import the other one. So import static java lang math dot 2 degrees, right? So we are explicitly importing this static method in the global scope of your Java source code, right? So var y is 2 degrees, and Eclipse autocomplete shows me that this static method is available for me, math.pi, all right, or pi over 2, and then sys out y. So pi over 2 is 90 degrees. We expect that. And again, we imported these, and obviously not only this applies to the static methods, it also applies to the static constants. So we can say import static java lang math pi, and then instead of writing math.pi, which kind of is ugly, we just say pi over 2, and Eclipse knows what we're talking about, right? The compiler knows that we're talking about java lang math pi. So this whole import business allows us to import a static, because a static methods and constants or variables or fields are fine. You can use them as if they're like in the global scope by using a static import, right? So that's the way this works, and it makes life easier. Now Java also allows a wildcard. So a static import wildcard, which is the notation is asterisk. I can say import a static java lang math dot everything. So this means import every static member. This means both fields, static fields and methods. So, and this is typically what we usually do for utility classes, right? Now the best practice is to always be explicit. So I'm going to write it again. Best practice is to do it like this, be explicit in your static imports. Well, actually the best practice is to don't use static imports, write everything. If you want to use pi, say math.pi, but usually this gets ugly, so we say, okay, let's go with a static import. Wildcard is acceptable as long as there is no name clashing. Basically wildcard imports is fine as long as there is no name clashing. What do we mean by that? Let's say in the constants we also have a pi, which is a static, so I can go ahead and import it statically, right? So let's run this for make sure that this code works fine. Our wildcard import works fine. We make all these static fields and methods available in the global scope of this source file of this class, right? So every class in this that is defined in this source file is going to see this method declaration as global functions or global variables, right? So Java provides this kind of behavior, but then what happens if we have two utility classes? So import a static and then know that the constants class is in the same package. I don't need to say fully qualified name, so I can suggest constants, and Eclipse's autocompiler autocomplete automatically writes it down, and then asterisk. Now note that I said that we don't need to do this, but that's actually not true, right? We need the for the import statement, we always need the fully qualified name. But Eclipse's autocomplete is very helpful, right? So for import, that's the whole purpose of the import statement, to tell Java we always need a fully qualified name. That's the whole purpose of import statement. You have to tell Java, hey, when you see this name constants in this source file, then it's actually it's in this package, right? Now as you see, as soon as I apply this wildcard, I get a compilation error for pi because the field pi is ambiguous. Why? Because now there are two static imports. Now there are two static variables that are defined as pi, and both of them are opened up. So both of them are available in the global scope of the source code, and the compiler doesn't know which one we're talking about. And know that these two are basically identical. I mean, obviously to the compiler, this pi is different from the pi in the math, because these are in two different scopes, in two different classes, right? So the compiler doesn't know which one we're talking about. Now, what's the solution? Obviously, the solution is, first of all, avoid using wildcard. The other solution is that you have to disambiguous, make it disambiguous, or remove the vagueness manually by fully qualifying the names. So what this means is that instead of saying this, we have to tell the compiler which pi we're talking about. I can say math.py. That's fine, right? Then the compiler knows which pi we're talking about. Or I can say constants.py. And now the compiler knows that we're talking about the pi that is in this class, in the scope of the constants class. All right. So if there's a name clashing, you have to be careful about how to resolve those, and those go manually. But these functions, 2 degrees, 2 radians, these typically are right now there is no name clashing, because these two methods are only available as static methods in the math. So when you deal with utility classes, especially in scientific libraries, be careful not to open up or not to statically import every function, because it could clash with other static imports. So try to avoid wildcards for static imports as much as possible. All right. But again, know that in the bytecode, obviously JVM replaces these functions with the fully qualified name. So in the bytecode, JVM says java.lang.math.2 radians, right? The compiler, not the JVM, the compiler does that. So in the bytecode, the compiler writes this, because JVM, when you run your application, JVM needs to know where to look for this method. And it's supposed to be inside this class, and this type, math, is in this package. All right. So JVM needs to know where to look for stuff so that it can execute your program. The compiler provides this information behind the scenes, but then the Java provides some sort of a static import mechanism so that you can avoid writing the fully qualified name for the static methods and static fields. Again, static fields and methods are supposed to be some sort of freestanding functions. Java doesn't allow it because there is no global scope, so you kind of end up with this static imports to open these functions up so that you can just type the name of the function. Because eventually, if there's a function in the global scope, you can just type the name of the function. The compiler has to know what you're talking about, right? Knows what you're talking about. Now in C++ or Python, the name of the functions are actually the pointers to where that function is. So name of the function are function pointers. In Java, we don't have such concepts. So the best we can do, we can tell the Java compiler what a static function we're talking about, and then we can make it available through a static import. So static methods, if a method has a static modifier, then it should be invoked with a class name without the need for creating an instance of the object. That's what we're talking about. You can do it imported statically, and you don't need then to even write the name of the class. You just write the name of the method. The compiler knows which method you're talking about. Note, you can also refer to static methods with an object reference, but this is discouraged because it does not make it clear that they are class methods or static methods. A common use for a static method is to access static fields. For example, we could add a static method in the bicycle class to access the number of bicycles. A static get number of bicycles, return number of bicycles. Note, not all combinations of instance and class variables and methods are allowed. And we've looked at this before. You cannot access the non-static part of the state of an object in a static context, right? That's not allowed. Instance methods can access instance variables and instance methods directly. That's fine, right? Instance method is supposed to deal with the state of the object, so and the instance and then change it if possible. So non-static methods can access non-static fields and methods. That's fine. An instance method or a non-static method can access class variables or static fields and class methods. So non-static methods can access both the static fields or a static state and static methods. Class methods or static methods can access class variables or static fields, and class methods or static methods directly. And this is the same thing that I mentioned. In a static context, which means a static method, you can only access a static part of the state of the class. So a static method can only access static fields and static methods. Static methods or class methods cannot access instance variables, which are non-static fields or a non-static state, or instance methods or non-static method. So it's obvious why a static method cannot access a non-static variable. But why is it that it's not allowed to also access non-static methods? That's because a non-static method might be accessing non-static fields, right? So basically, it's what it says is, let's say we have int x equals to 5, right? And then we have a helper method here, and then let's have a non-static. And non-static in a helper class, for example, a non-static method might be just private int let's say get x, int get x, just something simple, and then return x, right? And then right now I'm getting a compilation warning saying that you have a private method, you've never used it anywhere else, so there is no point of having it, but I'm going to use it right now. Now in the helper method, we can access, let's say var y equals 0, and then return y. Let's write something to return, because if I don't return anything, I get a compilation error. Now we can access the static fields. In a static context, we can access any part of the static state. So we can say pi, for example. And note that we don't need to, as long as we are in the scope of the class. In the scope of the class, obviously we don't need to qualify these, because when we say pi, the implicit scope obviously is the scope of the class. If I want to say that this is pi in the math class, I have to qualify it explicitly with math.py or java.lang.math.py. But here when I write pi, obviously the compiler knows that this is supposed to be this pi. As long as we are in the scope of the same class, we don't need to qualify. We don't need to qualify static members, right? Because when we say pi, compiler knows what pi we're talking about, or at least it makes that assumption that this pi is the same pi in the same class, right? Now we can say we can access static fields. We can also access static methods, right? So let's say private static double some value, and then return 5.1. So var, let's call this y1, y2 is y1 times some value. Okay, so we can access a static, no problem, and then let's return y2. Now note that what happens to the basically color coding and font coding. As you can see, the static method in the declaration, it's the same font, but Eclipse is smart enough to kind of, when you invoke the method, it italicizes that so that you know that this is actually a static method, right? Without looking anywhere else. If I just look at these lines of code, it tells me that, hey, this pi is a static member because all the fields are blue color. Local variables are brown. So this tells me this is a field, but because it's italicized, this tells me this is a static field, right? Same with some value. This is a method, obviously, because it has round brackets, or which means this we are invoking this. And then because it's italicized, it means it's a non-static, it's a static method. And obviously there is another rule, is that in a static context, you can only access static fields and methods. So if I say var y3 is y2 times get x, as you can see, the Eclipse's autocomplete doesn't have any basically suggestions, and we get a compilation error. And you can guess what the error is. It says that cannot make a static reference to the non-static method get x from the type constants. What this saying is that, so let's write it down. What this says that I cannot call this getX method because this is non-static method, but then you're trying to call it in a static method. So we get a compilation error. All right. So I hope you enjoyed this lecture and now have a better understanding of basically static methods. We will continue and finish up this the rest of these basically items in the future lectures. Please stay tuned and I'll see you in the next one.